Hi guys. I really wish I were there, but I have teacher training today, and so you have a substitute. This video is to help guide you through what's going on today. The first thing that I would like you to do is, can you go on Schoology after you've chromed it up and select practice mass versus weight, because I've included the key right here so you can check your homework. That's number one. Number two is we are going to do an activity called practice net forces. In each situation below, determine the net force acting on the box. You can neglect gravity for this section. So for example, in this free body diagram, I see 1 Newton going to the left and 4 newtons going to the right. So if I wanted the force net, I would say all the forces going that way plus all the forces going that way. So if I'm going to say that that way is, let's say, negative, I could go 4 newtons in this direction plus negative 1 newton in this direction, and that gives me a grand total of 3 newtons. Can you complete the rest of these free body diagrams? When you flip it over, they get a little bit more complicated because now I'm talking about both the y-axis and the x-axis. Once you get to 7, 8, 9, and 10, now I want you to draw and label free body diagrams and then find the net force. You may not neglect gravity for this section. Let's assume we're on Earth, okay? So a 500 kilogram car. So here's a car, and we know that this car has 500 kilograms, but I want to figure out the force due to gravity and the force normal. The forward force provided by the car's motor is 3,000 newtons. Force motor. And the force of friction acting on the car, force of friction, is 1,000 newtons. And now, can I do a net force in both directions? I need to figure out what the force due to gravity is, but I know Newton's second law, mass times acceleration, and I have mass here. Can you complete this for question 8, 9, and 10? Once you've completed the things that I've asked you to do in class, check the key and do your net forces worksheet. Now comes the challenge, and I call this the Great Lego Balloon Escape. Here we go. The evil Lego Darth Vader has imprisoned some Lego heroes in his island fortress, which, guys, is like your lab bench. Can you help them escape by using a balloon to carry them to safety? Here's what I want you to do. I would like you to build a vehicle using Legos that could transport 1, 2, 4, or 6 Lego figurines and attach it to a helium balloon in the middle of my lab station. This is what you want to do. If I know what the force of the buoyancy is, that's an up force of the balloon, and I know a particular number, can you predict how much force in this direction your Lego bricks should be in order to get it to float in the middle of the room? Not go straight to the ceiling and you go into space and die, and not down to the floor and you fall into the sea and get eaten by sharks. So, okay, I will have already labeled the balloons with what their force buoyancy is. Your job and your partner's job is to build a vehicle that you can attach either by plugging it into the Legos or hooking it onto the paper clip. And you can attempt to get it so that that vehicle and balloon hover or float or are in equilibrium in the middle of the room. If you're able to do that, take a snapshot, take a selfie of yourself, and then maybe we can build a free body diagram. If you're interested in the optional activities, I leave that to you. That is above and beyond what I'm asking you to complete. But I'm asking you, please be nice to my substitute and hey, have a good weekend. I'll see you on Monday. Peace out.